So this is T off. Okay. So once you have your switch on, then basically you have, like in this case, like you would have an RL circuit. The inductor starts absorbing energy. So and we have seen the working mode of an RL circuit. Let's say like if the inductor has an initial current at this point, then its current starts increasing. Okay, and when the switch is on, output voltage is gonna be the same as Vs, so our voltage, it's gonna be positive as well. Okay, once the switch is open, then we have this circuit, right? So in this case, the energy stored in the inductor starts releasing into the circuit, into the resistor. So at this point, the current is gonna drop down exponentially. And again, we assume that we are in the steady state mode, right? So the current, it's gonna reach, let's assume that it reached its initial point, right? And the voltage, it's gonna be 0. And this keeps going on. As simple as that. So this is basically the operation of class A chopper. You can see here that the average voltage is always positive, and our current is also always positive, right? So that's why, like we say, that this is a first quadrant chopper. So it only operates in the first quadrant, and you can always see that the power flow is always from source to the load. We never have power flow going from load to the source. So always power flow is, in this class, is always from source to the load. Okay. Once we have the switch on, we store the energy inside the inductor, and once the switch is open, the energy stored in the inductor releases through this resistor using this freewheeling diode. Okay, so that was the first class I wanted to discuss. The application of that, as you can see, this is the case where voltage and current are both positive, as we saw here, right? So it means that the power is going to be positive, right? So this is for the case that we want to operate a motor in forward, like, and by forward, let's assume that we say like clockwise. And so this is called forward motoring. Okay, so you can use this class if you just like want to ramp up the speed of the motor in the in one direction, in the forward direction. Okay, so the second class I want to discuss is class B chopper. So let me remove this one. For the class B chopper, this is what we have. We have a diode in this direction, and we have a switch here, and we have an RL circuit. let's just like make this the model for a motor. So we have an RLE, right? This is how we can represent a DC motor. Okay. Again, let's see like what happens when switch is on and when switch is off. When switch is on, then if the switch is on, this voltage, it's gonna be like, if you assume that this point is grounded, this is gonna be 0, so this is gonna be reverse biased, where you can see that this point would be connected to the positive terminal, this point is gonna be connected to negative terminal, so this will be reverse biased. So we end up with just something like this. Okay, and in this case, our current, it's gonna go in this direction, right? Because this is the only source that we have here, and our current, it's gonna go in this direction. And what happens here is that this is the back EMF of the motor. So this is gonna charge this inductor, basically is storing energy in it, right? And once we open the switch, so this is the case where S is on. Sorry about that. When S is off, once we open the switch, now that we have stored some energy into this inductor, right? So in this case, the polarity of the voltage across this inductor is like this, because we are storing some energy into it. Once this becomes open, now there's an initial current inside the inductor, so keep this diode conducting, and this is what we end up with. This is RLE, and in this case, the polarity of the voltage across the inductor is like this, because now the current is, the energy stored in the inductor is released, so the current is gonna flow in the circuit in this direction. As you can see here, the power flow in Class B chopper is from the load through the source. So power flow in this case, it's gonna be from load towards source. Let me actually do it like this, from load towards source. Okay, in this case, L is charging, inductor is charging. In this case, inductor is discharging, right? And let's see like how the waveforms would look like. Okay, so in this case, again, let's assume that the inductor has an